Hi guys, are you working on Power BI projects and need a checklist for data transformations that you can apply on any type of data and get it right every time? Then watch this brief video till the end. In the real world of BI, an engineer must regularly apply a range of transformations in various data stores to keep up with the ever-progressing business and tech requirements. Without a clear strategy, we can easily overlook bad practices and end up in a messy situation from where rollback could be a nightmare. There are various methods, functions, and ways of transforming data in Power BI, which can be quite overwhelming. So I decided to share with you my top 5 tips for data transformation in Power BI, which I religiously follow in my day job as a full-time consultant and advise my peers and fellow developers as well. Tip number 1. Data transformation as upstream as possible. What are upstream and downstream systems? Let's look into this simple diagram where Power BI is importing data from the SQL Server. We can see that SQL Server has 3 layers: sync, confirmed, and consumption, which is a typical enterprise layering model. Consumption layer here is a conceptual term. In your infra, it could be a warehouse or data mart or a queue. This consumption layer is feeding data into Power BI, and the very first stage is Power Query Editor, where we will do a preview of data, some cleansing, shaping, and transformation before loading it into the final data model. Finally, report visualization will read data from the data model and expose insights to the end user. Since data here is flowing from a server to end user, the direction of the flow is called downstream. Majority of the data analytical solutions facilitate downstream flow. The idea here is to apply any possible transformation as upstream as possible, which means SQL Server should be the first candidate, followed by Power Query Editor and then the data model. Yes, you can perform some transformations in data model as well, which won't change physical form of the data but can produce useful virtually calculated tables and columns using DAX. Let's check out this example where we have two fact tables, sales and inventory. Sales table has sales amount and product, and inventory table has days in stock and product as well. Now the business requirement is to see a ratio of in stock versus sales for every product, which means we have to join these two fact tables first. We can achieve this by using merge queries feature in Power Query Editor. However, it would be even better to go back into the data source SQL Server and create a view on top of both the tables and just import the view directly into Power BI. This will offload the compute task from Power BI to SQL Server and help Power BI to store lesser data. This will make both Power Query Engine and Vertex Storage Engine deliver their optimal performance. Tip number 2. Shred data horizontally and vertically. Shredding data horizontally means only importing absolutely required columns. The data source tables may contain hundreds of columns, most probably all of which are not relevant for our data analytics solution. We should exclude unnecessary columns by using either choose columns or remove columns. It's highly recommended to go with the choose columns and select only the required columns. The benefit of this approach over another is that if in the future the data source table exposes additional columns, they won't flow into the Power BI model. This way, you will have a full control of what is getting loaded. Hence, it reduces maintenance. Vertical shredding means reducing the volume of the data before importing. It is extremely important to only import data which is relevant to the task on hand. For instance, the data source may contain data for last 20 years, but the business expectation from the Power BI model is to show trends for recent years only, in which case you should only import 3 to 5 years of historical data into the model. There are two ways you can reduce the data volume: filters and rollups. Like in this example, first we are filtering the sales table to import data only starting year 2008. This reduces the volume automatically. We can further reduce the number of rows to be imported by applying rollup or aggregation on the table. For instance, instead of daily records, we need monthly aggregation. First, we have to derive month column from the date and then apply group by to aggregate sales at month level. we can see it makes a big difference in the volume. Tip number 3, query folding is your friend. Power Query Mashup Engine can combine and convert transformation steps into data source native queries. Send it to the data source server and execute it there. Finally, bring the transformed output into Power Query Mashup. For instance, if you have a SQL database as a data source, query folding can convert your Power Query steps into Transact SQL queries and run on the SQL server and retrieve the outcome. We can see which Power Queries are converted to native queries by simply right-clicking on the steps. As we can see here, navigation step is converted to a native SQL query. This great optimization technique in Power Query comes as default, which means it will try to do query folding wherever and whenever it's possible. It works well in almost all queries which can be converted to select statements in relational data sources, supporting the basic query language. As a best practice, make sure to first apply transformations which can be query folded and native data sources can run them. Tip number 4, data cleansing and massaging. Traditional data sources such as SQL Server Warehouse or raw file feeds tend to contain dirty data, which is often in a raw form and needs cleansing and massaging. In this stage, you need to check the health and state of the data to transform it into a useful clean output to be stored in the model. We can check the health of the columns manually or use Power Query Editor's two out-of-the-box features, column quality and column profile. This can give us an overview of records containing nulls or errors. Following transformations must be on our checklist. First one is data type correction. For instance, instead of date time, we might need date. We can convert the data type using either the top ribbon or by right-clicking on the column header. Next step is removing nulls. There are a couple of ways to do that. We can click on the downward arrow in the column header and select Remove Empty, or hovering over column quality, we can click on the Remove Empty button. Alternatively, instead of removing nulls, we can replace them by more meaningful values, such as a hard-coded value or a dynamic value containing average or max of the column. This can be done by selecting Replace Values. Please check out my detailed blog on data cleansing rules in Power BI. Link is in the description. Tip number 5, data shaping to suit your requirement. Data sources contain generic data structures which can serve a wide range of requirements from various applications. We need to tailor the data according to our requirements. Let's look into this simple example. This schema will result in addition of a new column every week to store future weekly data. As a thumb rule, we should make sure that data must grow vertically, not horizontally. Try to imagine a table in a relational database or a tabular model which contains inconsistent column count, which increases every week you query it. Will you be able to query it efficiently in an automated manner and account for all the inconsistencies yet result in a consistent output? The answer is no. Also think about how Power BI's Wordpack storage engine processes data. It does an amazing job in terms of compression and storage when the tables have least number of columns and grow vertically in rows. Fat tables with a lot of unnecessary columns can increase size of the data model, which will take additional space in the cloud. To transform this example into a thin table with least number of columns and let the volume of the data to grow vertically by adding new rows every week, we will use unpivot function. After some relabeling, the results look good. To summarize, a good data lineage solution implements all required data transformations as upstream as possible and as downstream as necessary. This dictates which transformation will happen in which stage of data lineage. Before importing data into Power BI, make sure you shred data vertically and horizontally to only load just enough rows and columns required for the data model you are envisioning. Leverage query folding feature of Power Query Engine to offload heavy transformation jobs to the data source. Data cleansing and massaging techniques result in high quality, trustworthy data based on which you can build meaningful insights for the business. The raw form of data needs to be shaped into purposeful schema to build a high-performing data model. I've also written a detailed blog on this topic. Make sure you check it out. Link is in the description. If you have any question related to Power BI, please leave a comment down below. I will answer to my very best. If you found this video useful, please hit the like button and share with your fellow developers. Make sure you subscribe to this channel to stay up to date for amazing Power BI tutorials coming soon. I'll see you in the next video.